we are going to have a talk that generated a fair amount of discussion on the internet, wherein Jeff Denworth, who everyone knows, just only on the internet probably, but Jeff was talking about the pending death of the file system and whether or not that's a real thing. And Glenn, whom also a lot of people know for having a lot of thoughts about the future of not just file systems, but storage hardware and architecture. You were agreeing while also somehow sounding like you were disagreeing. So a lot of people dug into that conversation to figure out what was going on. But at the root of this, and I think why this discussion was so sticky for people, was because a lot of people are talking about this idea of whether or not the parallel file system is dead. So how did we even get to the point where we're having that conversation?
So I would say Glenn's in it deeper than I am on a daily basis, but it started with a kind of a random email I got from a salesperson saying, how can this very, very popular large language model be trained off of Amazon S3? And, for the last, 5 years or so, if you've been in deep learning and you talk to anybody that makes prescriptions on AI infrastructure, it's, GPUs, InfiniBand, and a parallel file system, and that's the prescription. And all of a sudden, I just saw this S3 thing happen, and I said, what the heck? And so then we had a conversation with NVIDIA. We realized that they were working on a new version of the NeMo framework that could do things like load data from object storage and could do checkpoints down to object storage. And that took me further down the rabbit hole of trying to figure out how people could even use checkpoints on low performance infrastructure. And there I came to the realization that a lot of the training frameworks were moving to be asynchronous. Asynchronous starts from the idea that you essentially you don't want to waste a single second sending data over the network if you can for a checkpoint, because while you're checkpointing, your cluster is virtually useless. It's just doing defensive I/O. And so if I can drop that into the CPU memory of a machine and then get back to computing, well, that's a better use of my compute time, right? And once you go asynchronous, that opens up the whole world of possibilities in terms of what type of storage solutions that you can use, at least for checkpointing. Restores are potentially a different problem, but that kind of made me realize that everything is moving object going forward, and that's a big problem for a lot of customers that have made file system only investments.
I'm sure, but that's the obvious investment to make for all these years. And you've invested in system architects who grew up using Lustre or GPFS, and it's what they know. So Glenn, you have built some very large scale storage systems that support massive supercomputers. How did you get to this point where you were questioning the vital role of the file system?
Oh, well, it's from very hands-on experience. And so I now work at Microsoft in the Azure team that supports our largest AI training supercomputers. And so if any of you know the top 500 list, the number 4 entry is this thing called Eagle, which is a Microsoft system.
Did you name it?
That's not its real name. Its real name is equivalent to like a UUID, which is free. Someone just came up with a marketing-friendly name for the listing. But it's like a slice of a much larger training supercomputer that my team manages on a day-to-day basis. And that supercomputer, despite being one of the largest, if not the largest in the world, has no parallel file system. And so, to hear people repeatedly, parrot this myth that, oh, well, you need a super fast, super expensive parallel file system to train AI models. Well, if the largest AI training cluster in the world doesn't have one, there's something not adding up there. And so, I know how our customer uses that supercomputer, and yeah, you don't need a parallel file system. And in fact, things become a lot easier when you don't have a parallel file system.
Oh, in what way? Like, what are some examples?
So I was recently visiting this customer as we were shaking out a much smaller H200 cluster. So we had just handed it over. We're qualifying the InfiniBand fabric. Fabric's going up and down, links are flapping, as we shake out parts of it. And it wasn't until someone used the phrase eviction in a non-storage context that I realized we haven't had any file system problems while qualifying this cluster. which is unheard of in my
Well,
experience.
because you didn't have a file system.
There's no file system. If links flap, the fabric goes down, the storage doesn't hang, you don't have stale mounts, none of that stuff happens. Just storage pauses, and then it comes back. And so there's a huge burden that just disappears in shakeout when we didn't have a parallel file system to worry about.
No one seemed to believe that either. Like that can't be true. They're hiding this somewhere. They're calling it something different, but it's still performing like a Lester-like action in the background. But
It's blob.
yeah, interesting. By the way, we've talked a lot about training. So you mentioned training, I think, and also objects. So I think inference is kind of a driver here too, right? How is inference pushing this trend faster?
So actually Jensen talked about it yesterday on stage with an announcement that he made around something called Dynamo. And inference is, inference is easily solved if you have a very quick session that happens on a machine. It gets complicated when you have long context windows and you have kind of long sessions that users or agents will repeatedly go back to. And the reason for this is because the tokens that are in a machine that help provide attention to an inference operation, well, the second that user disappears, you have to flush the cache because you got to make room for some other user that comes in. And that results in basically all that token data either disappearing, which is kind of really crappy AI services do that. But the good ones will say, okay, we're going to keep that session data and we'll come back to it later. Now, the interesting thing, and actually I think this is an argument in some respect against object storage, is that this token data, if you bring it from very slow TCP-based systems, it can take a long time to deliver back to any GPU machine within a data center that you may actually need to kind of revisit that session with. And so that's why some services try to just keep pinning a user back to the machine that they were on in hopes that their token data is still there, which is totally stupid. And so if they don't do that, then what they start doing is they start recomputing the entire history of that agentic or chat-based session, which means you're burning a ton of GPU time recreating the experience that user had previously. And so KV caches are the answer to that, key value caches, which basically allow you to kind of just enumerate tokens down to some either volatile or persistent media. And here, the third layer of kind of storage is, after you go GPU memory to CPU memory, is something that's persistent on the network. And what we're realizing is that object storage, kind of in the way that some big cloud vendors implement, I'm not going to pick on any, is pretty slow. And so there's now a case for things like S3 over RDMA, and there's a case for being very selective about the attention data that you bring back to a machine. We announced something called VUA, which stands for undivided attention, which is basically like an intelligent data serving mechanism that goes over GPU direct to GPUs that basically gives object data up to a machine in the form of key values, preferring the data that is most important to that session, which is essentially what people call attention.
Sure. Glenn, I mean, you've watched so many of these transitions over the years. What do you? I personally think, having covered the space for a long time, when I saw the details around KV cache, I thought, wow, this is cool. This is actually revolutionary. What are your thoughts on it from the broad perspective you have from way back in scientific computing to cloud and AI and inference and beyond?
Yeah, there's always been a lot of talk about KV caches in research circles for sure, because it is like a new way of interacting with data that in many ways maps more naturally to a certain problem at hand. It's widely distributed, but completely random access in nature. But it's always been a research problem. But I think inferencing is a case where there's money to be made by doing things very well, right? And being able to retrieve, like Jeff said, that context so that you're not recomputing and wasting a bunch of GPU cycles when they could be making you money, the key values pay for themselves.
Sure.
And so that's what's pushed us collectively in that direction. But my sense is it's still a very bespoke, special sauce kind of set of storage systems involved there. And so like my customers don't tell us how they do key value caching because that's how they differentiate and can deliver the most value for the tokens that they're serving up.
Mm-hmm.
And it deviates from S3 as a kind of philosophical concept because with S3 you have a set of APIs that Amazon kind of ratified, and the world mostly kind of rallies around the S3 standard.
Standard that wasn't a standard.
Right. But
Right.
now when you get into KV caches, the client is essentially like an inference framework, right? And so you have to start customizing the different interfaces between all these different platforms. And it's a little messy, I would say. Maybe NVIDIA can start to standardize this stuff, but I'm not sure they're even moving fast enough relative to how their customers are operating.
It's your job to move fast and take care of this.
It is.
So let's talk. I know this sounds like a really high level question, but there's a lot to unpack here. How are workloads changing, not just from a store and beyond the obvious stuff? So we all know AI and inference and how these things work and evolve, but one layer deeper, what's changing about workloads that's going to push people who haven't taken the step beyond file, for instance, to go ahead?
I can go.
Yeah, take it back.
So I had a conversation with a customer yesterday who spends a lot of money, spends billions of dollars a year. And the conversation ultimately distilled down to two types of flows that you have within, let's call it a pipeline. And that pipeline can actually extend across multiple data centers anymore. Synchronous flows and asynchronous flows. So what needs to be synchronous are things that have to happen in real time. A user gets on a machine and wants to continue like an agentic or a chat-based session. Well, you need to very quickly deliver the data back into that machine so you don't have to go recompute a session. That's something I would consider like a synchronous flow. A restore, right? So, there's a lot of AI infrastructure that's being built right now, and people are moving really quick, and sometimes these machines break and they're pretty fragile, like Glenn mentioned. And so a synchronous flow for most customers is like, when I have a job fail, I need to get that data back into the right place at the right time as quick as possible, or else somebody's going to lose a job. On the flip side, asynchronous flows are things that don't necessarily need to be completed in certain times. So data loaders have the understanding of what's going to happen from a scheduling perspective, and you have the luxury of time to get the data into the place it needs to be. Checkpoints are now asynchronous, and this was never the case for the last 20, 30 years.
Is that a game changer or what? The checkpointing, what a hassle that was for years. But anyway, Go ahead, Jeff. Yeah.
What it does is it gives you so much more GPU time back, because if I can checkpoint to local memory, that means that there's no amount of network or disk time that you need to spend to do defensive I/O, and clusters have just gotten more productive as a result. And people don't understand that, and it's crazy, like people that are writing multi-billion-dollar checks don't understand that memory is always faster than storage. And so the storage market is kind of like all just trying to, instill fear and doubt about, like, you're going to need something or otherwise you're going to get cancer. And it's like, no, like that's not the way it works. And you have to really understand the application pipeline to have intelligent discussions. And I think a lot of people bring some HPC mentality to the table that isn't relevant anymore.
Yeah. No offense, Glenn. I'm just kidding. You're on the bleeding edge of it.
Well, I'm guilty of it too.
But you come from that world. Everybody who does storage and has done it for more than a decade, who knows anything, has come from that world. If you're building systems at scale, you have certain things that you can't get around. You've got Lustre, GPFS, or Spectrum Scale, we're supposed to call it now, and you've got MPI and all these things that are, I thought it would be a gradual replacement, and it's just nope, move, and you've got this entirely new system architecture. In terms of workloads, I'm surprised no one mentioned RAG at all, and I'm sure you have some thoughts there on how that's reshaping systems and architecture.
Well, what freaks me out the most is that pre-training used to be the name of the game, right? Like people would spend hundreds of millions of dollars pre-training a large language model. And as core, that's a pretty typical HPC problem. There's checkpoint and there's restart. It might be asynchronous in the case of pre-training, which is fine, but it's largely a bulk synchronous job that runs across thousands of GPUs. And like, I get that. But we're now moving into the world of test time compute, where there's HPC workloads in the critical path between, your infrastructure and your revenue. And so suddenly, you could get away with a lot of sins in the bulk synchronous world of training. Like if the job crashes, nobody cares, because as long as you get the new model out by the end of the year, you're fine. But if your customer requests are constantly being interrupted because everything is so fragile, that's a much bigger problem. And the way that you have to shore up your storage infrastructure to support both a wide breadth of incoming HPC type requests from customers without letting them fail before they can return the results, that's a very difficult infrastructure question to solve.
Yeah, Jeff, I know you have thoughts on that.
Oh my gosh. I don't even know where to start with that one. I'm still kind of hung up on the RAG thing. I feel like Glenn half answered that.
No, that's okay. That's good. That's worth spending some time on. But I think Glenn made some interesting points here about changing philosophies. So address that real quick.
What do you mean by, give me an example of an HPC workload that happens within a pipeline?
So like if you're like with test time compute, you're having to generate tokens and then you reconsume those tokens.
Yeah.
And anything that happens during that kind of stateful process will interrupt the result that you produce back, right?
When you say test time compute, are you talking about like just chain of thought?
Yeah, reasoning models.
Okay,
that
yeah,
sort of
yeah.
thing.
So my general perspective is that you're right. The IOs have to be real time just because then it's things that you won't even know get requested until the model says, okay, I need this data. And in general, my observation is that chain of thought, kind of generative models now change the paradigm from, if you think about kind of old like transformer-based approaches where you just have to like pre-train a model with a ton of data, that model becomes a parrot. But now with test time computing and chain of thought, what you have is models that are becoming data processors. They're just, it's like the modern equivalent of the SAS Institute, where you just have business logic or some sort of like research logic that can be applied towards understanding the corpus in a way that humans can't. And so then vectorization comes in. RAG comes into the discussion because AI models need to talk to data structures that they understand, and that typically is vectors or some sort of like data that's enumerated in a data warehouse or a database that you can do like SQL operations against. So Glenn's working on stuff that those models won't come out until what, a year from now, 2 years from now in certain cases. And I think about if you kind of play it all forward and you think, okay, well, where is the market going with respect to this data processing paradigm? Today, these RAG projects that customers have are pretty like, they're still in their infancy. They're just kind of research in most standard enterprise organizations. There's huge RAG projects that are also like very serious, like at Meta and OpenAI and places like that. But the market on the whole is still kind of getting their feet wet with this. But if you kind of take these models that Glenn's customers are working on and say, okay, in 1 to 2 years time, they're going to understand data relevance and data recency and all of the context, then what will then happen is that organizations will then want to kind of go and create embeddings across all of their data because they're going to want to make it available to these large-scale systems. And that's going to change data at the most fundamental level, because now we're not talking about standard interfaces that you talk to data with, like either POSIX or SQL or things like that. You're just going to have AI talking down to vectors that are the ultimate expression of context within a system.
Yeah. Glenn, do you want to talk about the RAG?
I have to confess a healthy amount of ignorance, because Microsoft has Bing, which is, at its heart, a very large, context database. And we have cognitive search. There's a graph database underneath it. Yeah. And so like we also have cognitive search, which is a graph database. And so all of this tooling is already at our fingertips. And so issues, pertinent to retrieving context aren't as big in what I do. No one really talks about that.
The kind of the basis for web search has always been similarity hashing, right? And similarity hashing then becomes the thing that you need for vector databases to understand, okay, like if a prompt comes in, it gets tokenized, here's the attention, and you just get the closest thing to that. That's how search engines have worked for the last 20 years. Yeah.
Jeff, I remember sitting in on an analyst briefing with you where you gave a great simple use case of that I think embodied what you just talked about, which is imagine the non-tech, blue chip company with its 100 terabytes of data, historical data, petabytes, I'm sorry. I should know the difference. I'm still stuck in the olden days where wow, terabytes. So they have all of this information from the dawn of time, from when they started collecting data up into all the ways that they can now pull it in and ingest it and use it. This sounds like the world is now ready for a complete architecture shift in how we think, not just about storage, which forever, as you know, was kind of an afterthought. I mean, it was like, okay, we're going to do this many GPU nodes and CPU nodes, and we're going to have InfiniBand here and to put some, we'll have a little bit of flash. Nobody thought about it, right?
Yeah.
So we have to now, I guess, think about, we as a technical ecosystem, about how do you architect this thing as a cohesive whole? And storage cannot be an afterthought in that. It can't even really be storage anymore, can it? It's like, it's a different thing. It's morphed into something beyond what we've always considered as, that rack of flash in the back. So let's talk about how that's happened and how that'll evolve and manifest in the data centers of, I was gonna say the far future, but everything changes so fast, 5 years from now.
Yeah. So I think about Glenn's olden days, where I used to work in high-performance computing centers. And half of the conversations I've been having here with HPC organizations that just have that collection of data that is, since the dawn of time. And every single organization says the same thing, which is we don't know what we have, right? If you've been around, let's say OpenAI was founded about 10 days from VAST. But most, let's say blue chip Fortune 100s, their average age is probably 50 years, 70 years. And so they've been accumulating data forever. And nobody knows what they're sitting on. And there's not enough people time or people resources to make sense of that. So it's just been the state that everybody's been working in for decades. And for the first time, now you have embedding models that can make sense of that data systematically and automatically. And so I think you're right. There's a redefinition that's about to happen on the back of things like inference microservices. And the term unstructured data will ultimately, be irrelevant as time goes on because everything will be queryable. And if that happens, then, we get back to that place that I talked about earlier where people are going to go and create embeddings on all their data. But I think the other thing that may happen is that you'll have mass data collection because now systematically you can make more sense and get more value out of data than you've ever been able to. And so that will change the definitions of storage and databases at the most fundamental level.
Sure. And blurring the lines of where compute happens too. I mean, if you've got, they were talking this week about, embedding GPUs directly in the flash and all this, all the lines are blurring. So,
Yes.
So what happens in that world? Not just at Microsoft, but you're kind of a visionary on, you've always seen what's going to be next in storage. So then what after that?
Yeah, well, I think you both raise a good point that, we're moving into a world where you no longer necessarily interact with your data by opening a file or an object and reading bits out of it and making sense, right? You want more out of that. And so you might not know exactly what you're looking for, but you rely on an index of some sort, vector database, GraphDB, to point you in the right direction. Then you rely on an LLM to tell you, what you want to know about that data. And as that bar raises up, I think there's no need to implement that functionality away from the data, right? That would be like, implementing a file system on your compute nodes and then just using block, like an old school SAN, where the storage is doing the dumbest possible simple things, and then you take all the intelligence move on your compute. That didn't really last for very long because the more and more smarts we could put in the storage, the more value you can, focus on retrieving from your compute side investment.
There's a bear case to that I just heard yesterday. We hired somebody who just came from Grok. Previous to that, she was in the DeepMind team. And she's supposing that it may also be possible where agentic workflows can just do computing where the data is and then do some sort of collective reconciliation of understanding across the internet. And so, Satya, the CEO of Microsoft, talks about things like SaaS is dead. And, most SaaS platforms are just CRUD databases. And now if you put some sort of GPT on top of that, you don't need user interfaces, and you're going to have, agents that want to talk to collectives of data sources all over the place. Well, that maybe they aren't in the same machine room and things like this. And maybe you just have these set of distributed processes that happen everywhere. And, some sort of I don't know, it's not really MPI, but some sort of data reconciliation.
Glue.
Yeah. Glue?
Glue.
Yeah, sure.
Right.
Some internet glue.
Yes. It's funny. I was going to conclude with the question about, hey, in 5 years, will anybody be using parallel file systems at all? And after this whole conversation, that just kind of falls flat. That question doesn't. It just sounds so out of touch with all the things that we're talking about and all the innovations. We kind of outran it. But where will that be? And where does it have to remain? And VAST can support it. So it's,
I think file systems give you some advantage that object storage systems don't, right? A simple example is just being able to make a change to a file. Let's say you've got a Word document, right? And you want to add some words. An object storage system would require you to go and at the infrastructure level, because the objects are immutable, you'd have to go write something new on the back of that, which is an extremely inefficient approach to dealing with storage. And so, but there's still mainframes in the market, right? And there's still tons of code out in the market that's designed for POSIX. And that was actually the LinkedIn post that I made that started this whole conversation, was like, customers don't need file systems anymore. And then I clarified it, so they don't need only a file system. Right. They need something where you're going to have different access methods for different pipelines, and you need more versatile infrastructure. And there will be a gradual transition. And if you get me into like my crazy mode, then I start to think like, well, will we need storage protocols anymore in the future when you just have like AIs that are going to be talking down to infrastructure?
No matter what it is.
Complete abstraction.
Yeah, of course.
Like POSIX is stupid, S3 is stupid. Like you kind of see these examples of AIs that talk to each other through these new protocols. Like there's this thing on the internet where like two phones are like booking travel. Like, right. Oh, you're an AI and we're an AI. So let's talk like AIs are beep, 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 beep. Right. And so who knows? But file as an interface, I think it's the context that matters more than the actual protocol anymore.
So what I've heard is parallel file systems are for Word documents in 5 years.
I don't know. Really big ones.
And you'll be chatting with them anyway, so you don't need to actually open files anymore.
Well, I was about to say who needs Word, but I realized I got a Microsoft guy.
Word is an excellent product. Especially with Copilot. I think as much as it's fun to beat up on mainframes and COBOL and the like, it's true. I mean, Fortran is still used in the HPC world. Files are more intuitive for humans to interact with. I mean, if you open a terminal, you know how to interact with your data in a way that with objects, you got UUIDs, and it's just kind of messy for people to play with data that way. So it'll still be around, but at very large scales, it's not always the most cost-effective or efficient way to interact with data. If you're doing a systematic pipeline that's fully automated, there's no people in the loop, you don't really need files. It's not adding a lot of value.
Yeah,
I agree.
All right. Well, that is our panel. So thank you, everybody, for having breakfast with us.